So for our problem, we had problem number 2, and the problem was a 5 kilogram projectile was launched at a 30-degree angle with an initial velocity of 20 meters per second. Now there were two forces acting on the object which affects its acceleration. There's the force of gravity, and then there's another force pushing in the negative x direction on the object, and that force is given as a function of time, where big A is a constant, and then multiplied by time. So what we need to do is we need to divide up the problem into x and y components. So we need to solve for position in terms of time for y in order to get the max time the ball is in the air, or the projectile is in the air. So we have acceleration in terms of time is negative 9.8 meters per second squared, and then to get the velocity we take the projectile's initial y velocity and then subtract that from the integral of the acceleration, and then this ends up being the y velocity of the projectile being 10 minus 9.8 t. Then we need to get the position in terms of time. So what we did was we took the integral of the velocity equation, which is 10 minus 9.8 t dt, and that equals y of t, which is the position function, is equal to 10t minus 4.9 t squared. Then, in order to find out what the maximum amount of time the ball is in the air, we set position equal to 0, the y position equal to 0, and we solve for t, and then we get t0, which is its initial position, and then its final time, where the height of the ball is 0, so where it lands, is 2.04 seconds. We have the max time that the ball is in the air. We need to solve for large A, where the x component of the projectile's velocity is always positive. So what we have is the equation for force is equal to mass times acceleration, and we're given that the force acting in the x direction on the projectile is a function of time, where force is equal to a constant, times time. So what we did was we took the force equation and we made an acceleration as a function of time, where acceleration is equal to the constant a times t divided by 5 kilograms. Then we need to solve for the x component's velocity as a function of time, which is equal to 20 cosine of 30 degrees minus the integral of the acceleration function, and that is equal to 20 cosine 30 degrees minus large A times t squared divided by 10. And then what we need to do is we need to set it equal to 0. So this would be the x velocity is equal to 0, and the time is equal to 2.04 seconds, because that is the most amount of time that the ball will be in the air. So then we just solve for large A, given these values, and we did the algebra. Negative 20 times cosine 30 is equal to negative A times the time squared, which is 2.04 squared, divided by 10, and then we try to solve for A. So with all this algebra, we got 173.2 is equal to A times 2.04 seconds squared, and then we got A is equal to 41.6, and the units is 41.6 newtons per seconds, because in the force equation of time, it's A times time, so we need to get a force. So 41.6 newtons per second times however many seconds will equal a force, and that is how we got our answer.